Thanks for coming out, and thank you to all the organizers, sponsors, everybody here that's making this conference possible. I'm really thankful to everybody here and also excited to share this with you folks. So sorry, I'm gonna go a little bit faster since, my technical issue at the beginning here. But a little bit about me. My name is Kyle Oba. I'm from Honolulu, Hawaii, and expressed in UTC offsets, this is how far it is. I come from a company called Fathom Information Design. I'm a developer there, and I'm working in collaboration with a lot of folks. So what I'm sharing is a collaboration of a project with a lot of us working on it. In fact, everyone at Fathom has touched this project in one way or another. Fathom's a small group of designers and developers and people who cross those boundaries in one role in Boston, Massachusetts. We build custom software visualizations, we work with data, and we build custom data tools. So it's sort of like that's our thing. This is an artist's rendition of our office. And incidentally, if anyone here has heard of the processing framework, the office was founded by one of the co-creators of the processing framework. So you might notice some philosophical ties to what I'm presenting from the processing world, notably sketching in code and learning through building. Okay, so Operation Outbreak. So that's what I'm here to talk about. It's informally known as OO. You hear me use that acronym a lot. It's a simulation activity. We're using a mix of physical and digital interactions. I'll call the physical stuff analog sometimes. The outbreak and spread of a virtual pathogen is simulated. So OO essentially simulates the spread of a pathogen using mobile Bluetooth. And in simulation, students or participants become infected, display symptoms, infect other people, acquire protection through QR codes, and may recover. With Phoenix, we allow students to collaborate during the simulation, collect and visualize simulated pathogen outbreak data, and students analyze the data from their outbreaks, learning how pathogens spread and how their actions play a part in the spread or containment of pathogens. Different students participate in different roles that mirror real life. These roles include healthcare workers, government, public health, biomedical researchers, bankers, so on and so forth. I'm going to discuss the different technological components that we built and how we help the OO team translate what started as a purely physical analog activity, kind of like a board game, into a mix of digital and analog actions that help streamline and improve the overall experience. The OO concept and simulations are shepherded by the OO Outbreak team. So I put the URL up there. So it's housed at the Broad Institute of MIT and Harvard. OO is now a multi-institution collaborative initiative involving the Sabeti Lab at the Broad Institute and the Inspire Project and the Colubri Lab at the University of Massachusetts Chan Medical School. So I definitely won't be able to do the entire team justice, so please check out the URL if you'd like more information. So just a quick bit of history. This is what it started as. There's a lot of papers, stickers, and people acting out their roles, nothing digital. So it started out completely analog. Originally, simulation was acted out. Students would pass these stickers, as you see here, and pathogen would spread in that manner. The first simulation was from 2016. So by the time we built the digital experience, there was a wealth of experience and history to draw from. Eventually, we moved into digital, or the team moved into digital, and while it was initially analog, we wanted to sort of streamline things. So when phones were added to the mix, sort of as a way to simulate the pathogen in a manner that sort of more closely modeled real life, using mobile Bluetooth, kind of like a COVID-19 tracking app. But even with the app, the simulation was sort of complex to set up, and the team wanted to move to a world where teachers and student groups could get up and running on their own without somebody being there to sort of do it for them. They wanted a way for the rules to be programmed in, and so there would be less bookkeeping, so that the experience could flow a little smoother. They wanted to sort of drastically simplify all the sort of bookkeeping and setup work. So that's where we came in. All right, so we're not getting to the end of the conference. We're pretty much near the end of the conference, and so I wanted to introduce a very personal analogy to keep things interesting, tie my slides together, and sort of introduce you to something that's really important to me. So one of my favorite ways to spend time is freediving. I love it. I love freediving. This is a shot from a recent dive. I think it's amazing. I was very lucky to swim with these dolphins. And put simply, so what is freediving? So put simply, freediving is essentially diving underwater and holding your breath. So more technically, freediving is about understanding your body's innate ability to stay underwater. So every one of us possesses the mammalian dive reflex, which lowers our heart rate and relaxes us when our face touches cold water. So you might have seen people like splash cold water on their face before they go to bed or something like that to relax them. It actually works. So here comes the analogy. So when your face touches cold water and you hold your breath, you trigger the mammalian dive reflex. Every human has this. So your heart rate goes down and you relax. So this allows you to stay underwater longer, all right? So when you stay underwater longer, it increases your chances of seeing things that you wouldn't normally see. Okay, this is very, okay, 1, 2, 3, I won't go into it. Cool, so this is not, okay, so bear with me. So this is not unlike our journey to learn about the innate abilities of LiveView and by extension, Elixir and Phoenix. So through this project with LiveView, we've become familiar with what it provides. So as a team, and this experience sort of informs and constrains our use of this tool set. So this pertains specifically to our efforts to prototype and iterate on interactive data visualizations and highly customized data-heavy user interfaces. Very briefly on the design process, our process is highly iterative. We like to see the data on the screen as quickly as possible and interact with it as quickly as possible just to see what works. So we try things out, we build a lot of interfaces, and we throw away the ones that don't work. And we do this again and again until we sort of home in on what makes sense. We repeat this process, and all credit to the designers that I work with who are very talented. A particular story or a meaning will emerge or will pull from the data. All right, so why do we do this? So why follow a process of building and rebuilding over and over different interfaces? Why not just like start at the beginning and end at the end, right? We do this over and over. So why learn the innate abilities of the platform in this manner is another way of asking that question. Well, as in diving, when you relax and you dive down, you find new things. So when you're underwater, you notice new things. In this case, there's a porcupine fish sitting at the sandy bottom of this bay that I didn't see from the surface. The analogy here is that when you're immersed in building with LiveView or another tool, you can unlock the potential in your design process that you hadn't seen before. The tools enable you to iterate on designs using ideas you hadn't considered before. Okay, so that's sort of the journey that we went on. So I've sort of described that. And, but in more detail, looking back at that journey, I'd like to share with you what worked for us, what didn't work very well, and what we did to fix some of those problems when we were able to. Okay, so in order to talk about what worked, I want to take a brief step back and show you more about the application and give you a bit of an overview. We built the application with Phoenix, and so lucky for us, this means that we can easily support 1,000 people on this laptop. At least that's where I did a lot of testing. And we can use Elixir features to provide real-time updates to our screens. We replaced a number of legacy application components with Elixir, including the API backend. We updated the simulation creator application with LiveView, allowing self-service setup of a simulation. We created a new app for different stations used in the simulation, more on that later. These stations and their visualizations are based on real-life tools that we've built for pandemic surveillance. So we sort of have a split world, I guess, at our company where we do real-life pandemic surveillance and data visualization, and then also this sort of simulated version. And then for after the simulations are over, we provided some visualizations for a place for the students to review what happened and show comparisons between what the students think happened and what actually happened. So this is, I don't expect you to be able to read all these little parts, but this is the part, this is a slide that kind of gives you an idea that there's data being shared, right? So data gets shared between the different parts of the application and it gets complicated. The participants are interacting in the simulation using many different displays. There's the mobile apps, there's tablets for the stations, and then there's laptops for people that are doing like post-simulation activities. So more on those stations. So during the simulation, there's these stations where the students can role play different actors in the pandemic response. We created interactive screens for each station with customized activities for students to perform their assigned roles. And you can have as many of those screens or as few as you want. As each station performs their respective duties, inputting information into the simulation, in real time, their output is sent to the other stations. So you can see, I mean, this is an Elixir conference, so we all know that Phoenix sounds like a pretty good way to do that. Here's a small sample of some of those station screens. So this is the healthcare station. So this is one tab of the healthcare station, and it shows that as healthcare workers perform patient intakes or intake reports, this information automatically gets updated in the summary screen. This is one summary screen. Into the healthcare summary screen, and then also into the summary screens for the other stations. So things like the number of cases or the number of healthcare visits would be updated automatically or in real time. Yeah, and then also we might show something like the death toll, or we do show the death toll, which is input at the biomedical research station. This is another healthcare screen that shows the record that is used to record patient case intake reports. So this includes taking their in-simulation name, symptoms, diagnostic test through the QR code there that activates the test in the mobile app, and also assigning a virtual prescription by a healthcare worker. As the intake information is recorded, summaries of any open biomedical research, healthcare, public health station, their summary screens will be updated in real time. So you kind of get the idea there. So it's sort of like the sharing of information across the different stations. And then one final example is this government station, which is responsible for providing funds, so money, to allow the other stations to operate. So there's sort of like this timer in the simulation where if you don't have money, you can't work. And the money is used over time. So without funding, these stations are shown a stop work screen, and they can't do anything. As a government station adds funds to the stations, their funding status is updated in real time, and their screens switch back to the operational mode, such as this, or such as the screen you saw before, and they're able to resume their work. Okay, cool. So what worked? Phoenix's abstractions over real-time messaging are a unique tool set, in my mind, allowing you to explore exciting new ideas. So that's one of the main points that I wanted to make. This sort of this unique tool set allowing you to do things that you hadn't been able to do before. And maybe not unique in the actual functionality it provides, but how easy it is to deliver that functionality. LiveView's extractions over messaging enable rapid prototyping of new, previously inaccessible ideas. So just sort of like to harp on that like very briefly, the ease with which you can build those particular features make it easier for you to experiment with them. And I feel that learning through experimentation allows you to come up with better and new ideas. Going back to those stations, participants are filling in healthcare intake forms, and they immediately update the other stations. So kind of like, again, the deaths are shown immediately. So again, having these features work on day one is very nice. So channels are just waiting, the Phoenix channels are just waiting for you to use them. And the ability to rapidly prototype a message passing system is very nice and was totally new to us before this project. A key feature for us was also the government funding. So Phoenix allowed us to easily implement a mildly complicated bookkeeping system as a timing mechanism. So we did it very simply using channels and then some storage on the back end. All right, what else worked? LiveView plays an integral role in the iterative design process for us and required process which is required by us to explore and represent complex data. Phoenix makes developing new live views very easy, maintaining momentum during the iterative design process. It didn't slow us down, I guess is one way of putting it. Server-rendered live view front ends are fast and eliminate the need to add JavaScript until absolutely necessary. And for that, we sometimes leaned on the LiveView client hooks. So using WebSockets to pass data to live views and build server-rendered UIs allowed for some very quick iteration. That is until we got to larger data sets, and more on dealing with that problem later. So when do you actually need to provide some custom JavaScript functionality? When you actually do need to provide the custom JavaScript functionality, the JavaScript client hooks are there for you, and they provide a default way to handle the JavaScript lifecycle of these UI components. So why reinvent the wheel? Why not just use these things? So we did that by default, and it was very nice for us. So you sort of like delay all of that extra work. Tailwind CSS is a hit with our designers and allows us to keep the styling less complicated. LiveView components are very nice, and we're playing around with a lot of ideas for how to use those more. So far, we just sort of like create our own set for a particular project. But definitely check out Max McClure's talk if you haven't seen it from yesterday on LiveView and Tailwind. I learned a lot from it, and it's super, super well done. So APIs. We switched from a legacy API platform that would go nameless to Phoenix for the API layer. And the switch improved the API's performance drastically, allowing us to support larger simulations. Like I was saying, like we had like 1,000 users on this box, and it was great. But also, it did so in a very simple way. So it was very easy for us to isolate the slow spots and add caching very easily or simply. Okay, cool. So what didn't work? Mistakes were made. Sending large amounts of data over LiveView or WebSockets to LiveView can be a problem. So we ran into some performance problems as the visualizations we built on LiveView started to serve larger and larger data sets, right? When we're prototyping and we're iterating, we're just using like test data sets, no problem. But when the simulation started getting bigger, longer, and there was more history to show, that became an issue. So shoving a ton of data down a WebSocket is slow, and it eats up a lot of server memory. So just as an example, here's a data visualization that we might show, but the number of participants in this one is not very large, but in a larger simulation, you can see there's a lot of interactions happening, there's a lot of data, and it all has to get shoved down to the front end. Yeah. Here's another diagram of the relationships between individuals and group outcomes. So early on during the COVID-19 pandemic, there was much discussion about the idea that you don't always know how big your bubble really is. So having this ground truth data from a simulation allowed us to show how interacting even with a small group of people can really increase your chances of being exposed. So you have you in the middle, you have a first degree, second degree, and a third degree ring of interactions. We also wanted sort of like a thumbprint or sort of like a fingerprint of how fingerprint or way of visualizing the simulation as a whole that could convey the scale. So we tried a few different things, but this final network visualization works well to show the scale of the outbreak and how it's interconnected. Okay, so how do we fix this? So for the large data set problem, for some screens we switched away from LiveView and WebSockets to Phoenix, just a plain Phoenix controller, since sending files is faster and uses less memory. So the way that we do this is we stream from Postgres to a temporary file with a timestamp cache tag on the file name. And then we use the Phoenix controller send download function to push the data to JavaScript in just a regular JavaScript get call. So it's sort of like, here's all your data, and it stays out of memory. Okay, so what else didn't work? We're at ElixirConf, so we all know that distributed systems are hard. And sometimes they get complicated, and they're difficult to debug when they go wrong. So we found that it's best to keep the architecture as simple as possible for as long as possible. So keeping to monolithic application deployment has helped us maintain this application with a very small team. Introducing architectural complexity contributes to deployment complexity and is not fun when things go wrong. I think that's one of the strengths of Phoenix, being able to keep it simple for so long, if not for the foreseeable future. It's not for lack of trying. I mean, like, we definitely tried to make it more complicated and then pulled back on how complicated we made it when we found out we didn't need to make it that complicated. So it's not, yeah, so I'll leave it at that. But monolithic is pretty great. I definitely, I don't want to speak for anyone else, but Chris Cranger's talk yesterday about NX and his success in eliminating other language dependencies. And by extension, things like duplicate permissions from his project that really struck a chord with me, and I really liked the way he the way he phrased it. So it makes me happy about being able to do so much with such a small tool set. Okay, what else did we do? Distributed system, right? You're passing information all over the place. I like to name everything with structs. This is a little bit controversial at the company that I work at, but I like to think of LiveViews as data-centric, right? So they're essentially a render function on the map that you're throwing down the WebSocket, right? So we use structs to name everything we're passing around to the different screens. I'm sorry, not passing down the WebSocket. I'm sorry, it's like a render function on a map within the LiveView process. So naming everything with structs, right? As well as passing those structs around to the other parts of the application, right? So this is a little bit controversial because one argument against using structs everywhere is that it sometimes is quicker to just take a giant map of all your data and just give it to your LiveView so that your LiveView has everything, right? So there's a bit of a compromise there. So if you do the large map thing, right, it's easy and quick for rapid prototyping, right? Because you don't need to like make a bunch of changes in order to get data to your LiveView, right? So, but longer term, well, and let me just pause there. So for the front-end developer, right, you have all the data ready to go. You can do experiments. You can, play around with different representations of the data in the UI, right? Because you have it all there. You don't have to constantly go back and forth like passing the data in. It's just always there, right? But longer term, though, I definitely prefer to name the data structures that we're passing around the app with something like a struct. Then being selective about what I pass down the LiveView. Yesterday, Zach Daniels mentioned accidental languages, and that I thought that was a really great name for this type of problem, right? Like when I'm passing a map around, I don't really know what's in the map. I kind of, and then the map gets used in multiple places. So then you have these keywords around your application, and it sort of becomes like, in a way, an accidental language. So I really like the way he put that. Yeah. So this is just an example of what one of those things might look like. Population statistics. It has a number of different keys in there. It's very simple. This is what that file actually looks like. So when we're naming things with maps, with structs, the maps we're passing around are not free for all, right? The structs can confidently be constructed and turned into your assigns, right? We know what the keys are, and we have a way of looking up or documenting what we're passing around when we forget, right? We have a place to go to see what's in there. This documentation of what's in the message is essential when things get confusing. So after all, the two most difficult things in programming are caching, naming things, and off by one errors. All right. So cool. Thanks for indulging me. So one final point. So I have this green sea turtle here to remind me to say that if you put everything you learn together, you relax, you swim in it for a while, you iterate, new opportunities will present themselves. Sometimes, if you're patient, the curious Honu will come to you. Things just seem to fall into place. But this is a reminder to get immersed in the design details of LiveView and Phoenix and uncover exciting opportunities to build new things. All right, thank you very much. So go ahead. Well, I was going to say shout out to Monica Coles, one of the organizers, for helping me get here and taking care of so much stuff.
Awesome. Yeah, thank you, Kyle. Great talk. And we have one question on Hoover. We have a couple of minutes for questions. Sorry, my screen just. Is offline first for mobile stations a possible requirement in some situations? So no network.
You mean? I would say that sounds like a great idea. The good thing about this particular application or set of applications is that we have a lot of control over the environment. And also, like, just to be frank, we're sort of building this thing and learning as we're going. So we don't have that feature. It might be something that would be great to have, but it hasn't been something that we've needed so far. There's a lot of things like that I think we would benefit from.
Cool, thank you. Any questions from the room? Still have 1 minute? No? So yeah, let's give a big round of applause to Kyle again. Thank you.